So today in this class we will try to know little more about electromagnet. For that it is better if we make some comparison between a permanent magnet and electromagnet. That will reveal to us what the electromagnet is and how it is different from a permanent magnet. Usually the permanent magnet is bar magnets like thing. These are permanent magnets. Whereas electromagnet, as I have already told you, electromagnet means in a solenoid. If the core material is soft iron, then that solenoid becomes so electromagnet. So electromagnet, one way you can say, is assembly of a solenoid and uh, soft iron is core material in that solenoid. That together it is called electromagnet. So one thing that you can see is bar magnet thing like our permanent magnet, where electromagnets are temporary. As long as you supply electricity, this will behave like a magnet. Electromagnet will behave like a magnet, and as soon as you switch off the electricity, that is, you disrupt the supply to the electromagnet, that will stop behaving like a magnet. It is also not out of place if I mention one thing here, that in electromagnets, why we use soft iron only as soft iron use as core material, why not steel? See, as you know, at the moment electricity is switched off, the soft iron loses all its magnetism and it stops behaving like a magnet. Whereas steel is not able to lose all its magnetic effect. It is it still remains as a magnet even when the electricity has been switched off. So we say that using steel as a core material will make it a permanent magnet rather than temporary magnet. And electromagnets are usually, we are using them for temporary magnet. Then permanent magnets, the weak force of attraction they are able to develop. Whatever the strength, if I give you a piece of magnet, whatever the strength is there, it is there, and usually it is less. Whereas in electromagnets, you can have large force of attraction that can be produced. And those three things in the previous class we told you. One, the electromagnet can develop large magnetic force, that is force of attraction, by increasing the current, by increasing the number of turns per unit length, and also by decreasing the distance between the poles. This, after a while, we will see how that can be done. And so here we were telling that electromagnets are strong force of attraction they can produce. Then permanent magnets are having fixed strength. Whatever the strength is there, that is there. You cannot do anything with it. But electromagnet's strength you can change. And also the polarity in a permanent magnet cannot be changed. Whereas polarity in an electromagnet can be changed by reversing the direction of current flow. Now, since we are talking about polarity of electromagnet, we will also talk here itself about the clock face rule. Let me make two segments of a coil. Let us say this is one and this is another one. If I happen to find, when I am looking at a one end of electromagnet, it is electromagnet like this, a solenoid. A number of coils are there, and says I am looking at this end. I am looking at this end. This is an electromagnet. Large number of coils are present, and from this end, if I say I am looking at, and I happen to find that current is flowing clockwise. This is the clockwise direction of the current. So when current is flowing clockwise, this will make south pole of the electromagnet. South pole. And if I happen to find current is flowing anti-clockwise through the segment, if I am looking at here and if it is clockwise, undoubtedly from another end it will be anti-clockwise. Both the ends cannot become south pole, both the ends cannot become north pole. One has to become south, another has to become north pole. So at one end, if you happen to find current is flowing clockwise, definitely another end you will find it is flowing anti-clockwise. So when it is found to flow anti-clockwise, then that particular end of the electromagnet will form north pole. And this polarity can be changed by reversing the direction of current flow through the electromagnet. So this was clock. To memorize this, maybe after some time you will forget which pole forms a north pole, which south. This is not a very logical thing to follow, but just to make you remember. the term anti-clockwise, if I write here anti-clockwise, this contains N. Also north pole contains N. So anti-clockwise N, if you find it to happen, current flowing through the segment of the coil in anti-clockwise direction, that will form north pole of the electromagnet. And if you happen to find flowing in clockwise direction, then that particular end will make south pole. Clock does not contain N, south pole also does not contain N. So this was one thing. Another thing that I have already told you, in an electromagnet, we cannot use steel as core magnet because that will make it a permanent magnet. When the electricity is switched off, soft iron is having the characteristic that it loses all its magnetism, and that very moment when the supply is switched off, the electromagnet will stop behaving like a magnet. But in case of steel does not lose all its magnetism. The very moment electricity is switched off, it retains some of the magnetism and it will keep on behaving like a permanent magnet.